Part 2, previously we had multiplication and division, and now we have addition and subtraction, but now the idea is still going to be the same pretty much. It's still going to be a fraction. Okay, for multiplication and division, there's like no special condition for which like what you have to do in order that we can perform the operation. It doesn't matter for the case of multiplication and division. No matter what kind of function do you have, it's always possible to do multiplication and division right away. But for the case of addition and subtraction, so that is a condition. And the condition is that, so the fraction must have a common denominator. So the denominator must be the same, then only you can perform the operation. And let me remind you one thing. I know that you know this already, but I always come across students doing something like this. Like, remember when you have a plus b over c, yes, the numerator, you can actually so I'm referring to the top part right here. You can separate them. You can write this as a over c plus b over c. However, if you have a over b plus c, there is no way that you can actually write this as a over b plus a over c. So this is going to be completely wrong. So the rule is that you can change the numerator. So let me put over here. So you can change numerator, but you cannot do anything with the denominator. You can change numerator, but not the denominator. So the denominator has to be, you cannot simply separate them. Okay, so you can change that by multiplying and such, but you cannot simply like add or multiply something. You cannot simply like separate the denominator of a fraction. So that doesn't work. Okay, so these are going to be the example that I'm going to show you. And again, this is just revision for you. If you don't need this, so don't bother listening. So here, for fractions with different denominators, so what we're going to do is, the first step is to convert to a common denominator. So use the least common denominator. Okay, the rule is least common denominator. So I'm going to start with the first one. Okay, so I have 3 over a plus 5 over a square. So here what I'm going to do is, I know that the common denominator out of this is going to be a square. So I'm going to multiply top and bottom by a. So here I'm going to have 3a over a square plus 5 over a square. So now that the denominator is the same, then only I can perform the plus operation. So there I can write that. This is going to equal 3a plus 5, and that is going to be over a square. Remember, when they have the same denominator, then only we can plus or minus. And it only applies for plus and minus. Multiplication and division doesn't matter. Okay, second example. So I have 1 over 2x plus 7x, and that is over 10 y square and minus 2. And remember, we know that when we have a constant that is not a fraction, so this is actually 2 over 1. So that is how it's done. Okay, so what I'm supposed to do by this, I know that what is going to be the common denominator of them. So I know that everything is going to be over, so I have 2, 10 and 1. So of course, like the only way is the constant possible is going to be a 10. So I'm going to multiply the 2 and make it into a 10, and this one into a 10 as well. And I have x and y squared, so I have no choice that I'm going to have both x and also y squared. Okay, this one, how do I make it into 10xy squared? So I'm going to have to multiply the top by 5y squared, and the bottom is also going to be multiplied by 5y squared. Then only the denominator will become the same. And the second term is going to be multiplied by x top and bottom. And the constant is top and bottom is going to be multiplied by 10xy to the power of 2. Okay, so now all the denominator are going to be the same. They're going to be 10xy to the power of 2. So the first term is going to be 5y to the power of 2. So the middle term is going to be 7x squared. And the last term is going to be 20xy squared. So now, can you simplify this? Like, I don't think so. I don't think that there could be a way to simplify this. So just leave it like that. So that's the rule. Okay, so now that the denominator is the same, I cannot simplify the top, so I'm going to leave it like that. So that is going to be the second example. Okay, so the third one, I have 15 at the top, and at the bottom I have x squared plus x minus 6, and then I'm going to add this with x plus 1, and that is over 2 minus x. Okay, before I start with this, first of all, I'm going to check first whether this is reducible or irreducible. In fact, I think this is actually reducible. And of course, like I mentioned to you before, you can always check by using your calculator. So actually I can write this as 15 over, and this is going to be x minus 3x plus 2. I'm sorry, it's going to be the other way around. So this is going to be x minus 2, so x plus 3, and this one remains is going to be x plus 1, but I'm going to change the bottom because I noticed the pattern. So this can actually be written as negative of x minus 2. Remember, we can change the form as long as when I expand this, it becomes the same as what I have at the top, and it is. I'm going to have 2 minus x as well. Okay, so now remember, I only have to multiply with whatever that is not there. For example, what do I mean by that? For example, it's going to be something like this. Okay, let me put a column around right here. For example, let's say if I have 1 over 3 plus 1 over 6. So I know that the common factor will be 6. So therefore, there's no reason I'm going to have to multiply this 3 and multiply this by 6. No, I just simply have to multiply this top and bottom by 2, and it's going to become over 6. So this is going to be 2 plus 1. So that is going to be the same that I'm going to apply over here as well. So the thing is that this factor, I already have x minus 2, so this x minus 2 is going to be there as well. So therefore, I'm simply going to multiply this top and bottom by x plus 3. So that is what is not there. And again, so how do we deal with the plus and the minus? We know that plus multiplied by minus, that is going to be minus. And so therefore, what happened is that I'm going to end up with 15 minus, so I'm going to have x plus 1, so multiplied by x plus 3, and at the bottom it's going to be over x minus 2 multiplied by x plus 3. So let me add another page. Okay, I'm going to simplify the top. This is going to be 15 minus x to the power of 2, and at the top of here I'm going to have 3 and 1, that is going to be 4. Negative is going to be negative 4x. 3 multiplied by 1, that's a 3. Multiplied by this negative right here, so it's going to be minus 3. And that is going to be over x minus 2 multiplied by x plus 3. So when I simplify, I'll end up with negative x squared minus 4x plus 12. And that is going to be over x minus 2x plus 3. I had a feeling that this is going to be a bit long, because at the top here I can actually factorize it. I can write this as negative. So it's going to be x squared plus 4x minus 12, and at the bottom is going to be x minus 2x plus 3. And let's see what we can do with the top one, because the top one is actually reducible. So this can actually be written as x plus 6 multiplied by x minus 2. So I'm going to have 6x minus 2x, which is going to be a 4, and that will be over x minus 2x plus 3. So I can cancel whatever that is the same top and bottom. So therefore, I simply going to end up with a negative of x plus 6 over x plus 3. Okay, so that is going to be the outcome for example number 3. So now let's move on to the fourth one. So the fourth one is going to be slightly more complicated. I have 1 over 4b. So minus 1 over 3a, so it involves subtraction and also division. And at the bottom I have 5 over, so I don't know why my 5 become like 6 every single time I wrote them. So it's going to be 5 over 6b squared, and then plus 1 over a. Okay, so this is going to be humongous. Okay, the thing is that first, what I want you to do is, you are going to deal with them separately. So do not bother with the division first. You do the plus minus operation at the top and bottom first. Okay, so you do this separately first in order, then only you bother with the division. Okay, at the top, this is going to be over, I have a constant 4 and 3. So the common factor between them is going to be 12. So therefore here I'm going to have 12. So this is going to be multiplied by 3a, top and bottom. And here you're going to multiply that by 4b. Okay, so therefore my denominator is going to be 12ab. At the top, I'll end up with 3a minus 4b. And over, so now let's deal with the bottom part. So the bottom part here, so my denominator, so this is going to be over 6ab squared. So I'm going to multiply top and bottom by a, and I'm going to multiply this by 6b squared, also top and bottom. So therefore what happens is that at the top I'm going to have 5a plus 6b squared. Okay, so now that I've simplified my operation, so instead of having 1, 2, 3, 4, 4 terms separately, I have put them together. Now I only have 2, and I can actually now, I'm going to flip it around and do the division operation. So I'm going to write this as 3a minus 4b over 12ab. So divide is division. We know that when we have division, we can flip it around and we can make it multiply. So it's going to be multiply. You have to flip it around. So this and this is going to be reversed. So I'll end up with 6ab squared over 5a plus 6b squared. So now let's see if we can simplify them. Sure. So this is a 2. This is going to be 1. This a and b, a, and I'm going to have b to the power of 1. And this 2, they cannot be simplified, just leave it as it is. So therefore, when I simplify this, so at the top, I'll end up with, don't forget this b right here. So it's still there. So therefore, I'll end up with b multiplied by 3a minus 4b, or you can actually multiply them and expand, doesn't matter. So both are correct. And at the bottom, I'm going to have 5a plus 6b squared. So that will be the outcome for this case. So I'm going to have b, 3a minus 4b plus 5a plus 6b squared. Oh, sorry. I have another 2 down here. So I almost forgotten about the 2. So let's put it here. It's going to be 2 multiplied by the whole thing. Okay. So I know that I can no longer simplify this. So I'm going to leave it like that. So that will be for number 4. And the last one, number 5. So I'm going to have a pretty similar form. It is u minus 1 over u squared, and that is over 1 over u squared minus 1. I'm going to be pretty much the same thing. So for the top one, I'm going to make it over u squared. So here I'm going to have to multiply this top and bottom by u squared. So I'll end up with u cubed minus 1 over u squared, and it's going to be over. So here this is going to be over u squared as well. So I'm going to have 1 minus u squared. Okay, and then I'm going to flip it around because this is a division operation. So this is going to be u cubed minus 1 over u squared. So divide, we know that divide we can change it to multiply, but again this will be flipped around. So I'll end up with u squared over 1 minus u squared. So this 2 is going to cancel each other. Okay, but now at the top I have u cubed minus 1, and at the bottom I have 1 minus u squared. So let's see if we can actually simplify this. Let's see if we can actually simplify this further, because we know that this one can be simplified by using the what do you call that? The one difference in cubes. Okay, so I'm going to apply the formula. It's a minus, so therefore I'm going to have u minus 1. This is the formula. And then I'm going to have first term square, and minus is just at the front, plus both term multiplied, it's going to be u, and the last one is going to be 1 square, and that will be over 1 minus u square. Okay, 1 minus u square. So this, on the other hand, is going to be difference of what do you call that, square. So I can actually write this as, so where's my eraser? My eraser is here. So I can actually write the bottom as 1 minus u multiplied by 1 plus u, because this is actually 1 to the power of 2 minus u to the power of 2. So I simplify both of this, for which I'll end up with u squared plus u plus 1, and the denominator is going to be 1 minus u. So that's how I simplify them. Okay, what if you actually stop until here in your calculation in the test or exam? So when you do the rest of the calculation, you simplify, there will be marks for this. So if you don't do it, meaning that you will only end up with marks until here, so you will lose the other marks allocated for the simplification. So that's how it goes. So I prepared you some exercise right here with the solution as well, so you can try all of them. So this will be the end of chapter 1. It's a very simple chapter, and I'm pretty sure you would have no problem with this. Okay, so attempt then, and let me know if you have any problem.